Hey everyone, welcome back to the College Algebra playlist. In previous videos on this playlist, we've taken a look at several different types of equations, including linear, quadratic, rational, radical, absolute value equations, equations with rational exponents, and polynomial equations. I want to take a look at one more type of equation before we move on to inequalities. The last type is equations in quadratic form. So let's get started with that right now. Okay, here we go. Equations in quadratic form. Equations in quadratic form are equations with three terms. The first term has a power other than 2. Also, the exponent on the first term is double the exponent on the middle term. And finally, the third term is a constant. Here are some examples of the type of equation I'm talking about. Look at this blue equation. Notice that the power 4 is double 2. 4 equals 2 times 2. So that's what makes this equation an equation in quadratic form. We can make a fancy substitution, and transform it into a quadratic equation. More on that later. For now, let's look at the red and green equations, This first power, the question is it double the power on the middle term? And it is, In this case, 6 is double 3, And then over here, 2/3 is double 1/3, So these are all examples of equations in quadratic form, Let's look at a recipe for solving equations in quadratic form, We'll use this recipe to cook up some solutions, The first step is to identify the exponent on the leading term and verify that it's double the exponent on the middle term. Then we substitute a variable, such as u, for the variable portion of the middle term. Then we rewrite the equation so that it takes on the standard form of a quadratic. We know how to solve quadratic equations in standard form. So the next step is to simply solve. And then we replace the substitution variable with the original variable. So we go back and we retrieve our solutions. And to do that, we need to solve the remaining equations. It could be one equation or two or more. So let's try this out. Here we're asked to solve for x, and we have 3x to the 4 minus 2x squared minus 1 equals 0. The question is this exponent double the middle exponent? Is 4 equal to 2 times 2? And the answer is yes, So this is an equation in quadratic form, So let's say let u equal x squared, The word let is one of the most powerful words in math, It's a powerful word we can use. We're going to make this substitution to transform this equation into a quadratic equation, So let's look at the original equation like this, And everywhere we see x squared in blue, we're going to replace that with u. That's our substitution. And when we do that, we can see that we're going to get a quadratic equation. So here, from this step to this step, all I did was I got rid of the unnecessary parentheses, And then I'm color coding these constants here, Because we're going to plug these values into the quadratic formula. Remember my advice for solving quadratics. If the leading coefficient is 1, then you should try factoring. But if it's some number other than 1, then you should use the famous quadratic formula. So I have a in red here is 3, and b in green here is -2, and c in purple here is -1. So we can plug these values into the quadratic formula to get solutions for u. So this is what it looks like when we plug in those values, a, b, and c. And we can simplify this, -2 is +2, and then under the square root, this is 4 minus -12. So it's 4 plus 12. And then on the bottom we have 2 times 3, which is 6. Let's take this result to the top of the screen. So under the radical, I have 4 plus 12, which is 16, all right? And that's a perfect square, all right? So our answers are going to be rational numbers, all right? I'm going to get 2 plus or minus 4, whole thing over 6, all right? So this, plus or minus, right, this is going to give me two solutions for you, okay? I have 2 plus 4 over 6, which is 6 over 6, right? And I have 2 minus 4 over 6, which is negative 2 over 6, all right? Both of these can be simplified, right? 6 over 6 is 1, and negative 2 over 6 reduces to negative 1/3, okay? So these are my two solutions for u, all right? Let's put it in blue, all right? Because we're going to use our original substitution to retrieve our solutions for x, all right? U equals x squared, that's what we said, right? Okay, so instead of u equals these two numbers, we're going to say x squared equals these two numbers, all right? So that gives us two equations that we need to solve, all right? We have x squared equals 1 and x squared equals negative 1/3, okay? So let's solve these two equations right now, all right? Let's take this result to the top of the screen, all right? And let's start with the equation on the left, all right? What I'm going to do is take the square root of both sides, all right? And on the left-hand side, right, that leaves me with x. And on the right-hand side, I have plus or minus root 1, okay? And the square root of 1 is just 1, okay? So our solutions are x equals plus or minus 1, all right? Let's look at this equation on the right. Okay, I have x squared equals negative 1/3. All right, I'm going to take the square root of both sides, all right? And on the left, that's going to give me x. And then on the right-hand side, that's going to give me plus or minus root negative 1/3, all right? Under this radical here, all right, let's rewrite this as 1/3 times negative 1, okay? And then let's split that into two different radicals, right? And we have the square root of minus 1 here, right, which is defined to be I, okay? So our solutions here are complex, all right? So this is pretty interesting. We're getting 4 answers here, right, which is to be expected, right, because the original equation was degree 4, okay? We get 2 real solutions and 2 complex solutions, all right? So let's visualize this, all right? Here's the curve that represents this equation, all right? And the equation we just solved was this blue one right here, all right? We got x equals plus or minus 1 and plus or minus square root of 1/3 I, okay? So we can visualize the real solutions, right? Because that's where the graph crosses the x-axis, all right? We have plus or minus 1, okay? So these points are given as negative 1 comma 0 and 1 comma 0, all right? Let's try one more, all right? Let's try to solve another equation in quadratic form, okay? Here we're asked to solve for x, and we have this big thing, all right? So the first step is to check, is this exponent double this exponent here? All right, there's an invisible 1 here. Remember, algebra is about seeing what isn't there, all right? So we need to visualize a power 1 on this x plus 2, right? Because we're asking, is 2 equal to 2 times 1? And the answer, of course, is yes. All right? So because of that, and because this is a constant here, this equation is in quadratic form, all right? Which means we can make a fancy substitution, all right? Let u equal x plus 2, all right? And let's rewrite the original equation like this, right? X plus 2 is in blue. Okay, so everywhere I see x plus 2 in blue, I'm going to replace that with u in blue, all right? The next step is just to get rid of these unnecessary parentheses, okay? And that leaves us with a trinomial on the left-hand side, and this trinomial is actually factorable, all right? The leading coefficient is 1, so we should try factoring, all right? This is factorable, right? We can factor it as u plus 12 times u minus 1, all right? If we were to FOIL that, we would get this expression here, u squared plus 11u minus 12, okay? So let's take this factored version to the top of the screen, all right? So I have something times something equals 0. So by the zero product property, I can set each thing equal to 0. All right? So now we just need to solve. Okay? Let's subtract 12 from both sides over here, and we'll get u equals negative 12. And you say, Luke, why is u blue? All right? And the answer is because we're going to harken back to our original substitution. All right? That fancy substitution we made. We said u equals x plus 2. All right? So now that we have this, we can retrieve the solution for x. All right? We can subtract 2 from both sides. All right? And we're going to get x equals negative 14. All right? That's the answer in the x realm, right? We made a transition from the u realm to the x realm. All right? So this is one of my solutions, right? X equals negative 14. Okay? Now let's go back to the u realm to solve this equation here. All right? Let's add 1 to both sides, right? And that gives us u equals 1. All right? So let's replace u with x plus 2. All right? And then let's isolate x. All right, let's subtract 2 from both sides, and we get x equals negative 1. Okay? So we solved the equation in u, and we made a transition to 2 equations in x, right? And we got these 2 solutions. All right? Let's visualize these on the coordinate system. All right? This parabola represents this equation, right? And we solved this blue equation here. All right, we solved this equation in x. All right, we got 2 solutions, right? We got x equals negative 14 and x equals negative 1. All right. So both solutions are real, so we can visualize them on this graph, right? That's where the graph crosses the x-axis. All right, so these are our 2 points. Okay. So that's how we can solve equations in quadratic form, right? We make a u substitution, and we solve the equation in u, and then we make the transition back to the equations in x. All right, that does it for this video. Thank you for watching, and like and subscribe.